Section 12.2, we're going to look at surface areas of prisms and cylinders. So we'll find surface areas of both of those and we'll describe what that really means. So again, here's the anatomy of a prism. It's a polyhedron, just to review, a polyhedron with two congruent bases that lie in parallel planes. So again, these bases are parallel to each other. And all of the other faces are called lateral faces. And again, the lateral faces are usually quadrilaterals or rectangles. The base can be any shape, but the lateral faces are rectangles or quadrilaterals in general. Okay, so again, just reviewing some things about prisms. It is a polyhedron with the two congruent bases. Again, we're just kind of reviewing this because from past experience, students tend to sometimes get mixed up between whether something is a prism versus a pyramid. So you have the congruent bases, but then remember that all of the other faces, okay, are everything except the bases, and we consider all of those lateral faces, and they connect the corresponding vertices of the bases together. So again, remember we talked about lateral edges versus faces versus bases and vertices. So turns out that you can actually have right or oblique prisms. A right prism would be where each lateral edge is perpendicular to both bases. So if we look at this lateral edge, it's going to be perpendicular to both of those bases. Oblique, the lateral edge is not perpendicular. So you can see that this lateral edge connecting the bases is not perpendicular. And so we have right and we have oblique prisms. What you need to keep in mind is the height is always the perpendicular distance between the bases. So your height sometimes is drawn outside if it is not a right prism. So just something to, again, be aware of. So surface area can be thought of all of the flat surfaces added together. So if we take a pentagonal prism here and we unfold it, it would be the sum of all of the lateral faces and bases together. And so when you unfold it, you can easily find the area of each one of these pieces. Like this would be 15 units squared, and we have 5 of them. Write that a little bit neater. We have 5. So we could just take that and multiply it by 5. And then we could find the area of this pentagon right here, as long as it's regular. We don't know that right now, so we would have to do some work to see, but we could find the area of that and multiply it by 2. So that's really what's going to happen when we find the surface area. We're just going to be able to do it a little bit simpler as far as we'll have a formula. But again, surface area is the sum of all the areas of all of the faces combined. The lateral area is just the sum of the lateral faces. So again, the lateral areas would be these 4. The front, the back, and the 2 sides. So that would be like this, the front, the back, and the 2 sides. And then the other 2 are the bases. The net is just the 2D representation of all of the faces. So if we are going to find the area of the surface area of this, we can see that this is 8 by 8. So the base area is 8 times 8. Since all of the dimensions are the same, this is also 8, then we know all of the faces are exactly the same. So we would just have to multiply that by 6. So that would give us a surface area of 384 units squared. Now, when we calculate using the formula, or sometimes when you're asked questions, they want you to find the lateral area separately. And so the lateral area would just be 8 times 8, one of them, times 4. So our lateral area would only be 256 units squared. Then we'd have to add the base area, which is another 2 squares. So it says, draw a net of the right rectangular prism and find the surface area. Well, the base is that rectangle. And so when you draw a net, I'd start with the base and label it. This is 10 by 14. All of the other, here is your other base right over here, okay? But all the other ones are lateral faces. So the lateral faces right here and right here, etc., okay? Those are either 5 by 10, and they are also 5 by 14. So we can start by finding the area of the base. So the surface area would be 2, because you have 2 of them, that are 10 times 14. So that's your base area times 2. And then we can add to it, we can add the 14 times 5, or we have this one right here. So we can do this one. I said the 14 by 5, so that would be this one right here. So we would take 14 times 5, multiply that by 2, and then add to it the 14, or 10 times 5, excuse me. So those are all the lateral faces. So we had 2 that were 10 by 5, those are those 2 right here. And then we also had 2 that were 5 by 14 right here. And then we add up all those together, and that gives us our total surface area. So what you might not notice or see from this at first is if you look at this right here, and you look at this right here, we can actually factor out a 5. There's a 5 as a factor here, and there's a 5 as a factor here. So if we factor that out, we'd have 5 times 2 times 14 plus 2 times 10. And this right inside here, you have 14, and you have another 14. You have 10, and you have 10. And if you look at this right here, what is that? Well, that is just the perimeter of the base. And that is what we will use in our formula as kind of a shortcut to all of this. The 5 right here that we have, this 5 right there is this dimension right here. And what that is our height. That is the height of our prism. So calculating and adding these all together gives us our combined total surface area. I'm going to let you calculate that on your calculator. Make sure you have the correct answer. And then we can see if you have gotten it correct here. And you can check back to the notes to see. But that's where we get this surface area of a right prism formula. So the surface area of a right prism is capital B times 2. And that capital B is important versus lowercase b, which is the base of a side. The capital B is the area of the base. And then we have plus the perimeter of the base times the height. And this right here is what's calculating those lateral areas. So you have the area of the base times 2 plus the perimeter of the base times the height of the prism. And so it can be confusing, the height of the base versus the height of the prism. So you have to be careful and be conscious of what numbers you're using and where they fit. So let's go ahead and try this one together. So we have our surface area here. And our formula is the area of the base, that's capital B, times 2, plus the perimeter of the base times the height. So our base is a triangle. So if you look at, this is a triangular prism. There's your base, and there's your second parallel congruent one. So our surface area is going to be 2 times 1/2 the base of the triangle times the height of the triangle. So my height of my triangle is 3, but my base, I don't know. I'm going to have to find it. So I would take 3 squared plus b squared, my base squared, is equal to 7 squared, because this is 7 over here. And so what that gives me for my triangle, for my height, or my base of the triangle, I guess, is the square root of 40. So that is the area of the base. Multiply it by 2. That gives me both base areas covered. Now I'm going to work on the perimeter of the base. Remember, I said this was the square root of 40. So the perimeter of my base is 3 plus the square root of 40 plus 7 times, that's the perimeter of the base, times the height of the whole prism, which is 11. So those are the numbers that you will use to calculate the surface area. And of course, you could get a decimal for the square root of 40, but I'm just going to do that at the end. So what I get for my base area times 2 is 18.97. What I get for my lateral area is 179.57. So again, this is my lateral area. And it asked me to find the lateral area, which I did. And now it asked me to find the entire surface area. So I add the base areas to that and gives me a combined total of 198.54 units squared. And that is how you calculate using that formula. Now, these, again, depending on the shape of their base, can get kind of tricky, okay? Because here, again, we have a triangular prism, and it is a regular one. It's equilateral, and that also makes it equiangular. So that triangle area, so the area of the triangle is 1/2 the base times the height. So again, for my surface area, I'm going to take 2 times capital B. And so I do know the base, so it's going to be 2 times 1/2 times my base of 16. I know that. Now I need to find the height of that triangle. So what I need to work on finding is this height right here. So I'm going to do that by noticing that this triangle that I've just redrawn right here, that height splits the base in half, so that makes that 8. What I'm trying to find is this h so that I can plug it in. Well, remember, these angles are all 60, so this makes this a 30, 60, 90-degree triangle, which we have our ratios of x, 2x, and, x, that's my 2x, and there's my x root 3. So that makes my height 8 root 3. So 8 root 3. So we're going to have to keep using those, or you could use your trig ratios there too as well. Now let's work on the perimeter of the base. Well, the perimeter of the base is 16 times 3. So you have the perimeter of the base, 16 times 3, times the height, which this is the height of the prism, which gives me, which is 22. Okay? So again, it wanted you to calculate the lateral area. This is the lateral area. So the lateral area is 1056. We're going to combine that with base area, which is 221.7, And that's going to give us a surface area of approximately 1,277.7 centimeters squared. Okay, so I'm going to have you try this one. Again, you are going to have to try to find the surface area. And in this case, they're only asking you to find the total surface area, but it is giving you that it's right hexagonal prism with a height of 16 and all the base edges measuring 8. Okay, so see if you can do that one. You may have to use trig because this is a regular polygon. When you're finding that base area, remember you're going to have to use 1/2 the apothem times the perimeter. So I'm giving you a few hints here. To find the area of this base, you're going to have to use 1/2 the apothem times the perimeter, and you're either going to have to use trig, or maybe you'll be able to use 30, 60, 90 or 45, 45, 90 within that. But I'd like you to try that one and then check back to the notes to see if you've gotten it correct. So, working through this one is not really that much different, but again, it depends on what information you're given to how challenging the problem is. This is the base. Okay, so when I calculate the base area, we can see that it's marked regular and it's a pentagon. So for that base, I'm going to have to use 1/2 the apothem times the perimeter. Okay, then I'm going to add to that the perimeter of the base, which I can already find 7.05 times 5 sides, and then I can multiply it by the height right here, which is 9. Okay, so now what I'm going to do is I'm going to have to work on getting this apothem. So if I'm working on this apothem right here for this triangle, okay, I know that it splits that base in half. So 7.05 cut in half gives me 3.525. So now I need to use either 30, 60, 90 or sine, cosine, tangent, but this angle right in here, okay, I find that, remember, by taking 360 degrees divided by the number of sides, which gives me 72, which makes this angle right here 36. So I can't use any of my triangle 30, 60, 90 or 45, 45, 90. So what I'm going to have to use is opposite over adjacent, or tangent. So the tangent of 36 is equal to the ratio dividing A, or the apothem, by 3.525, or the opposite over the adjacent. So now when I multiply each side by 3.525, that will give me my A value is approximately 4.85. So now I can put that in there. This is my apothem, 4.85. So now, if I rewrite this down here, I have 2 times 1/2 the apothem, which I just found, is 4.85 times the perimeter, and the perimeter is 7.05 times 5. And then I'm going to add that to what I got for my lateral area, which is up here 7.05 times 5 times 9. So my lateral area is 317.25. Okay, how do I get, there we go. Okay, sorry about that. All right, so now if I add all of these together, this base area gives me 170.96 plus the 317.25. So that gives me a surface area equal to 85.48 and feet squared. Oh, no, sorry. That is not quite right. Sorry, those do not add up. That gives me 488.21 feet squared. So there's your surface area. Again, these get quite involved, but you can do it. Now, cylinders, they're not a polyhedron, okay? But we can kind of look at them the same way we look at a prism. So a cylinder is a solid with two congruent circular bases, and again, the bases are parallel. So you have this as a base, and then you have a base on the bottom. And again, you can have right or oblique, okay? But we're going to focus mostly on the right ones. But again, the difference is your height. Make sure you're always looking for your height, because it turns out if we draw a net of our right cylinder, we have these bases right here, and we know how to calculate the area of the circle. And it turns out that this curved surface right here really is just a rectangle when you unfold it. So if you take a piece of paper and fold it up and then unfold it, you'll see. So what we have here is this right here is the height of the actual cylinder. And this right here, this edge right here is really comes from this, which is the circumference. So that's your circumference, which is like your perimeter. So it turns out the formula is going to be exactly the same. So we're going to take the area of our base, and since we have two of them, we're going to multiply by 2. So I have pi times 6 squared, that's the area of one of my bases, times 2. And then I'm going to add that with the perimeter of the base, which is circumference. So I'm going to take this times this for the rectangle, and my circumference is 12 pi times 15. That's just the area of this rectangle right there, which is really the perimeter of the base times the height, the same formula. So now, if we add these together, this would give us 180 pi, and this gives us 36 pi times 2, which gives us 252 pi. And when we add these together, it gives us our total surface area of, oh, sorry, this part is wrong. That gives the combined surface area of 252 pi, which is approximately 791.68 units squared. This part right here is actually 36 times 2, which is 72. 36 times 2 is 72. So that's where I messed that up a little bit. So 72 pi. There we go. And I just left it in terms of pi because it's less calculator work, but it turns out again that the surface area of a right cylinder is the identical formula. You take the area of the base is a circle, so it's pi r squared. So 2 times pi r squared plus the perimeter of the base times the height, which the perimeter of the base is 2 pi r, pi times diameter times the height. So you're doing the same exact thing. You're finding the base area times 2 plus your lateral area, which is just a rectangle. So find the lateral area and surface area of the right cylinder. I'm going to have you try this one on your own and then check back to the notes to see if you've done it correctly. Remember, you are going to find the lateral area separately from the total surface area. Let's move on. and work backwards on one, because these get a little more tricky and challenging. It says the surface area of a right rectangular prism below is 548 centimeters squared. So we already know the surface area. So again, I'm going to write my formula here. Surface area is equal to the area of the base times 2 plus the perimeter of the base times the height. Okay, so now fill in all the things you know. You know the area is 548. It gave you that. The area of the base. So here's your base. It's a rectangle, so it's 7x times 2. What's the perimeter of your base? Well, it's 7 plus 7. There's 7 over here, and another x. So the perimeter of the base is 14 plus x, or 2x. That's your perimeter of the base. And then the height of your prism is 10. So now you have all the pieces. And now we just need to start working on the math, the algebra piece. And that can get a little tricky. This is 7 times 2 is 14x. But what we need to do over here is use the distributive property, which gives us 140 plus 20x. Now we can combine the 14x and the 20x together, which gives me 34x plus 140 equals 548. And here the algebra is pretty simple. You subtract 140 from each side, and then you divide by 34, and that gives you x is equal to 12. So I found the value of x. And here's one working backwards. I'm going to have you try. It says the surface area of a right cylinder is 680 centimeters squared. If the radius is 7, find the height. Okay, what you might want to start with is a picture of the prism. That helps me. And here's your 7 for your radius, and you are trying to find the height. So go ahead and see if you can do that using surface area equals 2 capital B plus perimeter times the height. Fill in what you know and then try to subtract. It does get maybe a little bit trickier with the pi, but you could get a decimal for those as well. And that is the end of section 12.2.